The AI code editor Cursor is an Electron-based app. And what that means is that it uses Node.js to run JavaScript, usually web-based code to render web-based content, but with Electron running locally on your desktop computer. Now, there are tons of different Electron applications. Obviously Cursor and VS Code, but think Discord and Slack and Zoom and Microsoft Teams and Notion and Obsidian and Signal and GitHub Desktop. There are tons of these software solutions for the modern day software stack that run on your desktop with Electron. And you probably use these day in and day out. Well, just recently, my friend Bobby Cook put together an incredibly cool tool for penetration testing, red teaming, offensive cybersecurity work, and he built a Node.js-based command and control framework that backdoors Electron applications. He calls it Loki C2. So in this video, I want to set up and demo Loki, the Node.js command and control framework for backdooring vulnerable Electron applications. Now you can find this online. This is on GitHub, github.com/boku7/Loki. Let me scroll down to show you some background concepts in the description here. Loki is a stage 1 command and control for backdooring Electron applications to bypass application controls. And really, that's the heart of this, right? Because you're probably using Microsoft Teams or VS Code or Cursor. That's why I wanted to target Cursor for this demo, because, well, it leans into all the crazy AI hotness and what everyone's using already to vibe code and all that. Maybe you have Cursor installed and you could backdoor your system with this. This technique abuses the trust of signed vulnerable Electron applications to gain execution on a target system. The UI and the interface, kind of like graphics here, are pretty cool, but take a look at this description. At runtime, an Electron application reads JavaScript files, interprets their code, and executes them within the Electron process. They've got a cutesy animation that shows how Microsoft Teams, being an Electron app, could read a JavaScript file at runtime, but then use the Node.js child process module to execute any other program, like simple whoami.exe. Since Electron applications execute JavaScript at runtime, modifying these JavaScript files allows attackers to inject arbitrary Node.js code into the Electron process. By leveraging Node and Chromium APIs, JavaScript code can interact with the local operating system. It can run code on your computer. Arbitrary code, not just what it was meant to run in its own Electron app program. Loki was designed to backdoor Electron apps by replacing the application JavaScript files with the Loki C2 JavaScript files. He's got a lot more information in a sweet blog post, and I do want to reference that, but I am conscious this is a lot of really cool behind the scenes, some of the sweet intel that would be worth diving into in a whole nother video. Discusses a lot of the background context, tricks and things that you can do with Electron apps. I want to link that in the video description so you can see it and get a chance to look through it, but I won't drag us down the rabbit hole for this video on its own. Let's get to the demo for using Loki C2. And this will take a little bit of setup, but namely because of all the awesome features. This uses Azure Storage Blobs for their command and control channel. All the messages are AES encrypted. It uses a token to protect the storage account. It uses a proxy-aware agent so you can funnel that through whatever you want. There is no team server, which is pretty sweet. The GUI client and agents both check into the same data store for commands and output, and there's a hidden window, robust exception, blah, 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 you know, cool C2 server. The commands that Loki can run are what you would expect, but it is pretty neat. All agent commands are written in native Node.js and do not require any additional dependencies or library load events. They do have some stuff to do shellcode and assembly that do have a library load on keytar.node and assembly.node, but you can see everything that it might be able to do between spawning child processes, list drive, sleep, load, assembly, upload, download, blah, blah, blah. I'll let you drill down into this in the README, but I want to dive in to the party. For this demo, I'm going to be using 3 different virtual machines. The first is the victim. That's just a Windows 11 host right now. I've got that set up with light mode, so that's clear. That is the target. And on the attacker end, I'll be using Kali Linux to act as the adversary, and I'll also be using an attacker end Windows machine. That'll be set up in dark mode, so it's clear that's the attacker, but light mode is our victim. Now, let me actually get Cursor installed. Let me get the latest version of Cursor. You can download for Windows, nice and easy. That's 0.48.7 at the time of recording. I can open up that folder and install this program. Double-clicking Cursor setup, let me get this rolled through real quick. And actually, you might be able to see while this is installing a pretty interesting path. the /appdata/local/programs. You might have seen it as it was installing, but that is where Cursor typically installs itself, and it leaves behind, or at least places, all of the node.js or Electron files. That's a pertinent path that we'll explore very soon. All right, Cursor is complete. Let me click finish. And with that, let me get Cursor up and running just so it is logged in and it really looks like, okay, we've got the application going, because I want you as the end user, really victim target here, to have the concept, have the understanding that, okay, we are backdooring the program. Let's log in. Cool, that's all set. I'm logged in. Let's go ahead and get this cooking. All right, Cursor is running. Before we go too far with this though, we first need to make sure that the target Electron application that we've chosen is vulnerable to this, in that they don't do security integrity checks or ASR security integrity checks for the JavaScript and Electron files that they load in. There is a documented process for this, and Bobby's got us covered with a guide for discovering vulnerable Electron apps, or just making sure that this technique will work with whatever you try it against. Oh, hang on. Before we go any further, please let me take just a quick second to tell you about the sponsor of today's video. PlexTrack. You know how tedious pen test reporting can be. Hours of copying and pasting, organizing data from multiple sources, formatting findings. It's exhausting. And the worst part? Every minute spent reporting is a minute you're not hacking. There is a better way. Meet PlexTrack. With PlexTrack, you can analyze your attack surface, aggregate all pen test and vulnerability scan data in one place, use context-based scoring to prioritize risk, leverage artificial intelligence to slash reporting time, lean on collaborative Google Doc-like features for faster quality assurance reviews, and use out-of-the-box integrations with ticketing systems like Jira to send high-impact findings for remediation. So, what does this all mean for you? Well, you can cut pen test reporting time by 75%, collaborate seamlessly with teams and stakeholders, see your findings actually get addressed fast, and show measurable risk reduction. Charles Snyder, Director of Cybersecurity at CAI, said PlexTrack is foundational for our ongoing security and risk management. PlexTrack isn't just another tool. It's the difference between drowning in reports and actually having time to hack. Use my link below to learn more and book your own personalized demo. Spend less time reporting and more time hacking. Huge thanks to PlexTrack for sponsoring this video. So let's go take a look through this. Download an Electron app. In this example, they'll be using Teams. We get to try this against Cursor. You want to find the app root folder. It'll look something like this. Now, they were in App Data Local Microsoft for Microsoft Teams, but remember, when we saw Cursor installing, it was in App Data Local Programs. So let's try this out on the target victim machine. Now, let me say, of course, you can do this in your own attacker-based machine, in your own lab, anything that you'll do ahead of time to be able to test this. I'm really just doing it on the target and victim machine here because that's just where we just previously installed Cursor. So let me open up the Windows Explorer and the File Explorer. Let me get to App Data. In the location bar, I'm using the 2% signs as a environment variable. In fact, local app data will bring us there a little bit faster. Now I want to look for programs, as we saw previously. And inside of this, we see Cursor. Now we can see some of the other files that were very well suggested, just like their little description of what they saw in the Microsoft Teams folder, including Chrome pack and files like this. This matches everything that the guide suggests, and they state, okay, now we've tracked down the root app directory. Now, in this case, they have current, but in our case, it's just Cursor. They make a copy of it somewhere on our desktop, and they actually remove the contents of the resources folder. That will be very important. That's what we'll work with later, but they use procmon, or the process monitor from sysinternals, to try and take a look at what does the program actually do when it loads, when it tries to start up. Will it reach for app.asr or packages.json? And if it fails to find them out of the local directory, then we're good. Then that means, okay, we can clobber this, and the Loki C2 technique or trick will work just fine. So I'm going to jump up back to the parent directory so I can copy the entire Cursor folder, and just as they suggested, let's just drop it on our desktop for the moment. I'll paste this in with Control V. Oh, and it would help if Cursor was not running since that has programs and files in use. So let's try that again. Paste that in. There we go. It took me forever to copy. Okay, now in that duplicate copy on our desktop, in the resources folder, we want to remove everything here. I'll press delete on my keyboard, and then we'll want to hook up sysinternals and procmon. I do have procmon and sysinternals ready on this virtual machine, so let's get that going. I'll hit Control E to stop capturing, Control X to clear everything out, Control L to add a filter, and then we want to look for when the process name is cursor.exe, as you likely saw in that folder, and then we want to look for the path and whether it contains resources, and then we'll include those. Let's click apply and then OK, and then we can start capturing once again. And now I'll try to actually open up Cursor from this location. Let me double click on this folder that's on my desktop, but now you'll see, ooh, take a look at the sysinternals and procmon response here. It is going to try and look for resources app package.json, all the .asar files, and things that are name not found, but relative to our current location. So this is vulnerable, or vulnerable in that it doesn't do the security integrity checks, and we can put in Loki C2 files. That way we can backdoor cursor.exe and this Electron app. It's worth trying this for other Electron applications just as well. And this is the technique, let me be clear. When we have procmon capturing events, we can see the Electron app try to first look for the app.asr. If it fails, then it will look for the unpacked applications at packages.json. If that's happening, then the Electron app is most likely vulnerable to scriptjack. Sweet, we can continue. So to get started, we need to create an Azure Storage Blob account and get an SAS token. They do have documentation linked here, so we can click into that. Really, this is pretty simple. It is just following the steps to, hey, in your Azure account, spin up a storage account. Let me do that real quick. So I am logged into portal.azure.com, and I'm going to click into the storage accounts here. I'll click Create. Do already have that set up with a pay-as-you-go subscription with whatever resource group I might have already. The storage account name can be really whatever you want. I'll just use some random numbers here. Region is A-OK. The performance and the redundancy. I think the description suggests using a locally redundant storage, LRS, so we'll click OK on that. And then review and create. Once you've reviewed this and it looks good to you, we can go ahead and click create, and it will take just a little bit of time to spin this thing up, but with that, we should be able to then create the SAS token. All right, your deployment is complete, and with that, we can go to resource, and I'm going to zoom out just a smidge here because I do want to end up searching for, or at least looking in the security and networking end, I want the shared access signature tab, because with that, we can create our SAS token. A shared access signature, or SAS, is a URI that grants restricted access rights to Azure storage resources. And if you're wondering about any part of this, it is all in the documentation. They include the permissions that you might be able to use, the services, the types, and with that, we can go create this. They use blob, queue, and table, so we don't need file, resource types, service, container, and object. You can leave the allowed permissions, and if you wanted to set the expiry date and time, they suggested just about 8 months from now, so let's change that to, what is that, July? Yeah. Allowed protocols should be HTTPS only, and with that, we can generate SAS and the connection string. Now that that is created, I can use this in Loki. Now, for your awareness, we've generated this SAS token, but we'll put them into our client and agent configuration files in a moment, but that does offer full access to the storage account. So if the payload is reversed, they'll be able to use that SAS token to read the C2 channels, provided they also have the AS key, but it's something that you'll probably want to keep secret. Now that the Azure setup is done, we need to create an obfuscated Loki payload. We'll clone this repository, change directory into it, install Node, install JavaScript obfuscator, and then run this tooling so we can spin up an agent and enter in all the Azure account information that we've just received. So let me scroll to the very top here, and then let's clone this repository. I'll copy and paste that URL. And now over on the Kali Linux side, I'm going to open up a terminal. I'll hit Control-Alt-T on my keyboard, F11 to full screen, and I will move into my op directory where I like to keep a lot of my other extracurricular tools. Let's git clone Loki, and once that's pulled down, since we're in Kali Linux, we should already have Node and Node.js installed. I'm not quite sure if I have NPM. Oh, I do. Excellent. So let's move into Loki, and they may suggest using the JavaScript obfuscator to be able to obfuscate the agent. So let's install that very quickly. Okay, excellent. Now all we need to do is run our obfuscate agent script, the .js JavaScript file in this current directory, and this will ask us for the Azure account information that we just got set up. The first prompt for the storage account is just the URL for that storage account .blob.core.windows.net. So let's copy and paste that. I'll hit enter once I've provided that, and now it'll ask for the SAS token. That is asking for the second entry here, SAS token, and I'm going to click on the far right hand side where I can copy to my clipboard. I'll paste that info, I'll hit enter, and now it will spit out our obfuscated payload in the ./app directory. You might not have seen it previously, but now we have an app folder that actually includes all of the files that we'll need to replace or clobber what would be the target Electron application. In this case, Cursor. And now the reason that I have a third virtual machine in play here, I know another Windows machine, but this time an attacker machine with that dark mode background, that's because the Loki client, at least so far, I think only has a release build out for Windows. Back over in the repository, I think you could obviously compile this for Linux and play with it and work with it, although it's not super duper recommended unless you're doing development work, so I don't know if there's going to be one out in the way. I think Bobby has one in the works. I thought I saw a branch for it, but the Loki GUI client for Windows does have a release that we can download. So just for convenience, I'm going to paste this in here and then extract it and work with it over on our Windows attacker host, alongside, our Kali attacking host. But with that, I should be able to double click and open up Loki C2 client. And this looks pretty fancy, looking pretty slick. Loki dashboard, ooh. Now we do actually have to do something important here, because we have to configure the Loki C2 client to work with the Azure storage account and SAS token and the meta container that obfuscate agent script gave us. So bouncing back over to Kali Linux, just to be able to review this output, let me copy and paste all of the values that we've got. There is the storage account blob that we know and the SAS token that we know from Azure. We'll paste those in. But the meta container is new information that the obfuscate agent.js script gave us. So we'll need to copy and paste this value as well. Enter that there, let's hit save, and with that, the configuration is updated. Okay, at this point, we're just about ready to get our callback with Loki C2. But I do need to say, we still need to put all of these files, the Loki code, onto the target. And let me make sure this is clear. This is for command and control. You do need to have initial access. You'll have already compromised this victim, this target, and you'll have the capability to plop this code in so that it's infected, and now you've got this backdoor. With all that said, let me go ahead and copy all of the app folder contents into that location on the victim and target. And these changes should be made for the real app, right? Not the little duplicate copy we put on our desktop for testing, but over in App Data Local Programs, Cursor, in that resources folder, he suggested deleting everything. What I'm actually going to do, because I want to be able to play with this a little bit further, is just rename this. We'll call this like original-app. That way it's not going to be using, the hard-coded path that Electron would normally use. But let's paste in the app folder that we've got from Loki's obfuscated agent output. Now, that has everything that Loki C2 had prepared for us. And Cursor on this Windows 11 machine, in light mode, our victim and our target is backdoored with Cursor. So let me put these side by side and let's see if we can get a callback. So over on the left, I have the Loki dashboard from our attacker machine. Over on the right, I have the victim. And let me just press the start button here to open up the Cursor app as I usually would. Double click on Cursor and give it just a moment. Fingers crossed, we'll get our agent communicating back over on the left-hand side here. Fingers crossed. Okay, there it is. Excellent, excellent, excellent. Now, you may have noticed we didn't get Cursor to pop up over on the right-hand side. Let's talk about that in just a moment, but I do want to show you all the sweet stuff from Loki. Now that we have our agent, you can see the agent ID, the container, the host name, and I've double-clicked on it to open up the agent terminal. This tells us the username, the process that it's running in, process ID, IP address, architecture, operating system, blah, blah, blah. If I type in help, super simple here, and I'll full screen this, sorry. Obviously, we can see help commands, print working directory, list file and contents. Let's ls to see that we are actually on the target here. That will pull back all of the files in the current directory, and of course pwd will tell us what directory that we're in, and it's exactly as we would expect. But remember, you can do all of this other stuff, like sleep for a bit of time, list drives, spawn processes, move or copy files, execute shellcode, .NET assemblies, upload, download, whatever you want. It's command and control. And this is all running out of cursor.exe. But I know what you're thinking. Hang on, I wanted cursor to show up. So the victim, the user, the target, is completely oblivious to the fact that their app has been compromised. I'm right there with you. Let me open up Task Manager. Like, obviously, if we take a look at the details here, we can see cursor is running, but the process has been hollowed out to only do Loki stuff, not the regular usual cursor or Discord or Slack or Teams or whatever. I want that. So let me give you some backstory. Bobby and I are good friends. We've been chatting for many years at this point, and I reached out. He was telling me about the Loki C2 work some time ago before he finally released this, but it is very cool to see it up in action now. He gave me access to the thing way back in February, but I didn't really get a chance to play with it until now in April, and I messaged him like, hey, I'm finally playing with Loki, getting fired up, seeing it run with cursor, and it's going to be a really cool demo. But I'm wondering, is it supposed to not run the usual app? Because that would be cool. And he says, yeah, the Loki code hollows out the app and uses the signed Node.js interpreter, probably just cursor.exe in this case, to run the C2 code. It's of course possible to have the original app still running, but it requires a lot of work to rewrite the original app code to blend in with the Loki code. And then we started to think, hey, could we get a little bit crafty? I'm trying to think, can I still do it? Can we still figure it out with whatever files it's using out of the resources folder? I know we didn't remove the app, we just made it an original app copy of it to duplicate it. He says, maybe what you could do is leave the real cursor app as it is, then make another folder in cursor resources new folder, copy that entire cursor folder to that folder, and then modify their real main.js, or what the package.json file actually invokes, because that's really all this boils down to, right? What's the kickstart main script that this runs? And we started to play with this over the weekend, which is really cool. And I think his idea makes sense, but we're also cognizant that, okay, that means we are doubling the app size. So we both start to mess with it. I'm going to fall down a little bit of a rabbit hole here, but let me show you what I mean. Because when we open up our local app data, just as we did before on our target and victim here, looking in that programs folder, looking in cursor, and the directory for the resources and app. Now, we provided our own package.json in all of these files. If you take a look in the original app here, they actually don't have all those other files. They do have a package.json here that we can take a look at. Let me open this. I'm not going to do it with cursor because that'll get a callback. Do we have Sublime Text? No, we'll just use Notepad. Lame. But look, the main call here is to ./out/main.js. So they have this out directory that actually makes things kind of easy for us because all of it is contained in here. That is where they fire the actual cursor main.js. In our Loki C2 app, the package.json that we work with, opening with Notepad, not cursor, that will invoke our main.js. Now, our main.js is obfuscated. It looks like junk because we ran that obfuscate agent.js file. We don't have to, right, if you want the pure code in here to be able to play with this. But could we trigger or switch or work with, okay, the distinction between these two files and these two folders and basically have it keep cursor regularly running as pure original cursor window and GUI and still get our Loki callback? So I messed with this just a little bit, and I'm back in Kali Linux to be able to show you this thing. Obviously, our app main.js, as you saw, is the obfuscated one. But if we were to go back to the original, I think in the agent main.js, you can see this is the original startup, kickstart, actual beginning of when Loki fires up. This is what we want to maintain alongside cursor's usual invocation. So I tried to play with this, and so did Bobby. So I got something working, but it's not good. I'll show you all this, and I'll set the syntax to JavaScript. Look, I do whatever stupid, weird stuff in like the environment, the process environment variables to be able to tell if this is Loki actually kickstarting what will be the real cursor.exe, and it has to be another process, cursor.exe, because that's Electron. And if Electron is already doing Loki things, it can't in that same runtime do cursor things, just how it all ends up working. So it checks, okay, will it spawn its own copy of cursor and still do the usual startup? And I do that inside of a cursor original directory that'll contain actual cursor.exe, but a second rendition of it, not what you normally click on for your usual shortcut. I'll show it to you, but the setup is super janky. If we go back into our app, I still had the original app backed up, so let me remove the modified Loki one, add our original back in place, and I know this sounds horrendous, but I actually want to copy everything from the cursor directory on its own. So I'm going to copy this, and do I still have cursor.exe running? I do, yeah, okay. Let's kill that super quick, task kill /F to force, IM for image name, cursor.exe, please die. Okay, so I'm going to make a copy of cursor, and I'm going to put it back on my desktop again. I put it on the desktop just so it's not copying itself into itself in whatever like weird recursive tree branch file system logic. I'm going to rename this actually to cursor-original, as you saw, and then back in local app data, programs, cursor, resources in their real app, I actually want to put the full copy of the cursor app inside of this folder. So there's a duplicate cursor.exe inside of what we normally run, our cursor.exe. I know that's weird, and I know we are literally 2xing the size of this application, but when we get to copy over all of the Loki agent stuff in here and then modify the main.js to spawn that second one, that will work. It's not pretty, it 2x the size of the application, but it works. This is the first idea that Bobby and I got to kick around. Now, in app of real cursor, let's paste in all the stuff that Loki uses, and the only thing that really changes here is package.json, right? That's the only thing that we end up clobbering. But if I were to modify now main.js, let me use the one that I had shared with you just a moment ago and not the obfuscated one. I'm going to grab all of this code while this is a fine proof of concept, even though it's not pretty. Pasting this in, we should be able to see this run both Loki agent and cursor. So let's put these side by side again and see if it works. Okay, same setup. I'm going to remove the old agent since that one is dead and stale. But now Loki EC2, attacker on the left, victim on the right. If I open up cursor as I naturally would, just as a developer, as a user, fingers crossed, cursor pops up. We could actually use it, interact with it, and think that we're totally fine while we get our callback and it's backdoored. Once again, I have complete control and access to your machine, pwd, ls, copy files, do whatever we want. It's working just fine. I just want to demonstrate, okay, things are happening and it's a-okay. But on the victim side, the user is completely oblivious. They can get back to vibe coding. They can be messaging on Microsoft Teams. They can be hitting up in Discord voice chat, whatever. Let me add the disclaimers though. With that approach, we doubled the app size. Now, Bobby and I were cooking on this thing over the weekend, and he actually got it working with the better, smarter approach, where you just sort of hot swap what package.json actually calls. He uses a little bit of middleware or just an in-between thing in init.js. Then it actually modifies packages.json in place to spawn Loki and cursor, just flip-flopping back and forth. Originally, he got it working with just a one-time setup, but we end up making it persistent just after. Here's a really cool video that he gets cooking, and I let him know that I got mine working. I'll show you his video. Here, you can see he's in the actual cursor resources and app folder to remove inside of package.json the /out main.js with init.js. Now he includes this and then double clicks on cursor so that it will spawn and get a callback, still run cursor, and okay, cleaning up some old agents, but then you'll be able to see he's tinkering with the others, actually get invoked and still do the damage. Originally, that technique was just a one-time shot. And then I'm asking, hey, can I like showcase RDMs? Because this is really cool. And he's hyped up like, yeah. Now both ideas work, having a duplicate application to run alongside it or hot swapping back and forth the packages.json file. Now I'm asking, hey, can I showcase this? This is really cool because look, with a little bit more work, it could be made persistent so that every time if it hot swaps package.json, then you don't have to make any other changes. And Bobby's getting hyped up about this. It works. We got it. It's clean. It's persistent. Dude, this is an awesome capability. I'll probably use this on my next engagement. And I'm like, hell yeah. Now every Electron app ever can totally be backdoored. Now, I feel like I didn't do a very good job explaining that sort of hot swapping or flip-flop back between the package.json trick, but I'm glad that we got to kind of work on that, and I appreciate Bobby adding me into the README here with a little bit of kudos and credit while we got to nerd out on this over the weekend. Let me tell you about that thing, though. He added this new section here, backdooring Electron apps and keeping the real application working as normal. The most straightforward way to do this is the first time we showcased it, plop it in the files, and it hollows out or clobbers all of the original functionality of the Electron app. Loki just eats it. But when I got to banter with him, we were thinking, look, we could add a little bit of proxy app in the mix with that init.js that he put together. And this is for the demo that I was kind of scheming up. He says, look, if we download Cursor, paste the package.json file here, use the init.js file in there, and it will automatically end up these changes. Well, I don't think it's automatic yet, but you can see in this how this works section, it discusses how it goes back and forth between what the main script should be when it ends up running and then kind of putting it back in place from the packages.json file. But that way, the app is persistently backdoored and operates as normal. If the Cursor app is exited, Loki continues to run in the background. You still have your implant, you still have your command and control. And soon, that'll end up being automated. That's pretty sweet. It felt good to be able to contribute in a weird way, so thank you, Bobby, for throwing me into the repo. Really cool stuff here on OPSEC recommendations if you are using this for engagements. A little bit more intel on if you're compiling things from source. However, it's not really recommended if you're just using it. And there's some other info on detection. So if you're one of the blue teamers, defenders, hey folks doing things to help protect and secure organizations, really cool to see a lot of the MITRE attack techniques loaded here. And then examples of the Electron apps being ran or beaconing out to the Azure storage blob, etc., etc. Really, really cool stuff. I thought this was just slick, not gonna lie. I don't know about you, but now I'm thinking, hey, can we get this to work with Discord? Can it work with Slack? Can it work with Obsidian or Notion or however many whatever other Electron apps? Kind of crazy cool. And when it's set up as like a persistent backdoor, not doubling the app size and a copy of the whole application, but doing that sort of hot swap, understanding, okay, where in the package.json or the main script that gets ran or the init.json proxy thing, that's really, really slick. I know we did this with Cursor as the cutesy fireworks demo for the hot AI craze, but think about how this could be used. With all that said, kudos, props, all credit where credit is due. Big thanks to Bobby Cook for putting together this incredible Loki C2. Huge thanks for letting me hang out, kind of nerd snipe me over the weekend to be able to mess with it and jam a little bit more on it. And thank you so much for watching. Hope you learned something. Hope you had a lot of fun with this one. I hope this was a cool, flashy demo. And please do all those YouTube algorithm things like, comment, subscribe. And please do give some love to our sponsors. There's a link in the video description. Check them out if you're willing. And I'll see you in the next video.